Alright guys, tonight's notes are looking at seafloor spreading. This is the next piece in the puzzle of how the Earth's continents move around and how they get to the places where they are today. So we're going to talk about who discovered the theory of seafloor spreading, how it works, and what is the evidence for it. So let's get started. Seafloor spreading came up with by an American geologist by the name of Harry Hess in 1960, so only about 55 years ago. And what Professor Hess did is he used sonar, which is sound waves, to map out the bottom of the ocean. And so from his ship, he would send a sound wave towards the bottom of the ocean. It would reflect off the bottom and come back up. The longer this took, the deeper the ocean was. So by knowing the speed of sound, he could figure out how deep the ocean was. And he found out that the ocean floor wasn't flat. It had mountain chains running down the center of it. It had deep valleys, and this was a lot more complicated than people thought. And even more importantly, it turned out that these mountain ranges weren't just mountains, they were actually volcanoes. And that became super important in explaining this theory of seafloor spreading. Right, so main idea for this would have been Harry Hess, and we should have gotten some notes on how he mapped the bottom of the ocean. So how his theory of seafloor spreading works. So it starts at one of those mid-ocean ridges, those chains of volcanoes running down the center of some of the world's oceans. And these volcanoes basically create a crack in the ocean crust. Molten material beneath comes up, and older rocks on the edge are pushed away. And so these rocks around the ridge are pushed away. As this new molten material cools, it forms a strip of solid rock in the middle. And so the crust acts like a conveyor belt push. So you've got new rock coming out, hardening, pushing old rock away. More new rock comes out, pushes that rock away. More new rock comes out, pushes that rock away. And you can see that, if we go back to our map, this chain of volcanoes right here, as this creates new rock, it's going to push North America away from Europe. It's going to push South America away from Africa as these volcanoes erupt and push rock to the left and to the right. It's going to push these continents apart. So this kind of answers the original problem with Wegener's theory of continental drift, which is how do the continents move? It turns out that they're almost pushed by the seafloor moving. Right? That was Hess's idea. And he had some evidence for this. First evidence was evidence of volcanic activity. Right? He found rocks underwater that could only have formed from lava cooling. Right? And so rather than just the goop that people expected to find on seafloor, they found these hard volcanic rocks which formed when those volcanoes at the mid-ocean ridges erupted. Next up, they used evidence from drilling samples. So with a ship like this, you can actually drill down to the ocean floor, right? Kind of like the drill we talked about in class that bring up rock cores, right? You've got lots of pipe sections and you just drop the drill down through the water and then eventually into the seafloor. And it turns out that the farther you get away from the mid-ocean ridge, the older the rocks are. And so this is pretty important evidence because if you're close to the ridge, you would expect to find young rocks from when those volcanoes erupted. The farther away you got, the older the rocks got, indicating that those rocks had formed at the ridge a long time ago and had been pushed away. And the last piece of evidence is a little bit tricky, and we'll go over this more in class tomorrow when I'm back. And it was evidence from magnetic stripes. And so when the lava erupts, it has little pieces of iron in it. And this iron is going to, in the lava, it can move around and it can line up with the Earth's magnetic field. And so it basically acts like a little compass. And so when it cools, it gets locked into position, pointed towards the North Pole. But it turns out that the Earth's north and south magnetic poles actually switch over time. They'll switch positions just as the core rotates in a different pattern. We don't totally understand why this is, but we know it's the case because it turns out as you go away from the mid-ocean ridge, you get some rock where the iron points north and some rock where instead of pointing north, it points south. And you get the same pattern on either side of this central ridge, indicating that they both formed at the same time. Right? We'll talk more about this in class. I know it's a little confusing, and we'll do a cool little activity in class to kind of model this, and I think that'll help you understand it a little bit better. So we've got all this evidence, so people were like, okay, Harry Hess, I believe you that you've got lots of evidence to support this. The seafloor is definitely growing. But they had a big important question for him. Why isn't the Earth getting bigger? You're making all of this new crust, so the Earth should be getting bigger when this new crust is made. And it turns out that when one area of seafloor is growing, like in the middle of the Atlantic Ocean, another part is going through subduction, right? Which happens when some ocean crust in another part of the world is pushed underneath a continent and basically recycled back into the Earth. So these trenches are formed when the ocean floor pushes into deep underwater canyons and is eventually recycled back into the Earth. So while the Atlantic Ocean is growing from this mid-ocean ridge, the Pacific Ocean actually has deep trenches along the edges. And the crust that makes up the Pacific Ocean is being pushed underneath the continents, and the Pacific Ocean actually ends up shrinking in size. So the net amount of crust stays the same. New ocean crust here being formed, old ocean crust here being destroyed. And so you end up with no change in the overall amount of ocean crust. Pretty sweet. If you could live for another 300 million years, the Pacific Ocean would be gone if everything keeps going the same way. Excellent. All right, make sure you get 3 questions at the end of your notes, and I will see you guys in class tomorrow.